Hi, everyone. Good afternoon. We will begin our presentation in just a few minutes and after everyone logs in and gets settled. Hi, everybody. Thanks for joining us. We're going to get started here in just another minute or two. We'll give some time for other folks to log in and get ready. So we'll be with you in just a few minutes. Okay, good afternoon, everyone, and welcome to today's webinar, How to Streamline Data Sharing for National Security Missions. Today, you'll be hearing from a variety of different folks from Immuta and Starburst. And joining us, we have Nancy Patel, VP and General Manager of Public Sector for Immuta, Matt Carroll, Founder and CEO of Immuta, Justin Borgman, Co-Founder, Chairman, and CEO of Starburst, and Danny Holloway, Chief Technology Officer, Public Sector Immuta. Today, our speakers will be walking you through why the movement towards diverse cloud data ecosystems and data sources is necessitating a new approach to data access and control. You'll also hear how Starburst and Immuta empower DoD data teams to federate across cloud data platforms to optimize efficiency and maximize data value. And just a few housekeeping items before we get started. I would like to let everyone know that audio is coming through your computer speakers only and that all attendees are in listen-only mode. We will be recording today's virtual talk, and we will be sharing out a copy of that via email later this week. And finally, if you do have any questions during this presentation, please leverage the Q&A feature in the GoToWebinar control pane. All questions will be answered at the end of the webinar with our speakers during the Q&A. So now with that, I would like to pass it over to Nancy, who will talk a little bit about how data sharing has become a top priority for the DoD.
Thanks so much, Kaylee. And hi, everyone. Thanks so much for joining us today. You can go ahead and go to the next slide. I thought I'd spend just a few minutes setting the scene for the discussion today. And I figured what better way to start than this quote from Ms. Kathleen Hicks, our Deputy Secretary of Defense. This came from the Creating Data Advantage memo that was released in mid-May. I think it really just puts the point on how important data sharing is to the department and to the mission that they're prosecuting. Clearly from this and from the other recently released documents, the DoD is becoming a data-driven organization where everyone across the department has access and the ability to use data no matter where it sits, even in those siloed places that are maybe tucked away and hard to get to. It's really important for everyone to get this because that's going to make them more efficient and effective at prosecuting their mission. And it just allows easier access and quicker access for the department to make better, smarter decisions more quickly. But just to take a step away from this, I think it's not just a vision or a strategy, it's actually a full-scale change to the culture of the department. I see that there needs to be a reinvention of processes and resources across the department. But just as important, the department has to determine how to measure success and how to define success in this new data sharing and data first world. I really like this quote from Brigadier General Valencia. He talks about how the ability to share data and how to increase the speed to data. So just using this, I think 2 really important metrics for measuring success of a data-driven organization are how many users are getting to and using the data, but then also how quickly they can get to it. And to be able to do this right, it's not just about data sharing, but as you can see in the triangle, there's really 3 points that underlie that. It's securing the data, providing easy access, efficient access, and being able to both create and maintain governance over that data. So you see across the outside of the data ops triangle here in the middle are those 5 data decrees I talked about from Ms. Hicks earlier. I think it's no accident that number 1 is to maximize data sharing. And I really see the other 4 as underlying and supporting that data sharing approach and the importance of data sharing. So today, just to take another step back, we're going to talk about how Immuta and Starburst together can help enable this data sharing by consistently providing that access, as well as the governance and security needed to make it successful. So with that, I'll turn it over to Matt to jump into more details.
Thanks so much, Nancy. With that, what I would say is that data is becoming the product. So over the past 15 years since I've been working in the government, what I've seen holistically is that we've shifted away from building killer apps and have started to move towards providing data, whether it's timely and precise, to any end user. And so at the core of that kind of spirit, if you will, is this concept of the old world versus the new world. And so in the old world, we really cared about storage and we cared about manual work. So a lot of it was we would store the data, we would put it into SharePoint portals, we would then have Excel and we would analyze the data in Excel, and we'd keep all those Excel files on our, typically like external hard drives, or we'd have a NAS. For anyone that deployed would remember all of our PowerPoints and all of our Excel documents were all kept there in our little silos in our own AORs in the world. And then everything was about just massively structured data, right? So when we did work together in where we had like SIGAC tracking or signals intelligence, or even in the human world, we had to create structure out of it. In the modern world, what we're seeing is less about, we don't really care where it's stored. What we care about is how do we get access to it. It's much easier to access data. And we have to get out of the world of trying to just triage our own little Excel spreadsheets and get more into automation. How do we get insights? Getting back to like your commander's intent, if you will, it's like, how do I express the so what faster, right? And then how do we collaborate? I always use the example of I lived in one part of Baghdad, but just a street north of me, I didn't share any data with those people, even though it was very likely that the organizations we were targeting very likely crossed the street, right? So how do we collaborate with data effectively without necessarily having to have engineers on top of it? And then the ability to leverage any data and design reports and algorithms on top of that. This is the new world we live in. It's all about data. That is our focus. And the challenge is that we have to move from these siloed data teams where we have contracts where there's engineers built to service a very specific mission set or a very specific business purpose within the government, which is highly manual, expensive, and it doesn't really scale, to a new construct where it's not that it's one platform, rather it's just we have many end users that have the skills to be able to get access to that data and use it. Our modern workforce in the government, these new users, these kids have been, digital natives. A lot of them can understand basic coding principles like in SQL and figure it out. So they want rapid ad hoc access to many systems. Again, though, what I personally have learned in the government is you're never going to build one platform to rule them all. There's a lot of data gravity out there. And the reason is this, it's not just the number of unique sources or the complexity of data use agreements, but it's also just the mission, the entitlements around the data. What happens when I combine it? I have legal requirements to isolate this from others, so it has to be an enclave. So there's always going to be separated data stores, if you will. But there's general concepts that are emerging, whether it's cloud or on premises, which is you're going to have lakes of data. You're going to have modern warehousing, and you're going to have what we call no copy exchanges, because the data is too big to send petabytes of data across the wire between co-coms or between agencies. So the idea is the data stays within the lake or the warehouse, you leave it where it is, and then you virtually exchange it. And this concept allows end users to rapidly access data and get the precision they need and be able to start to become a data-driven culture. The challenge we face, though, is currently it just takes too long. And so a lot of these analysts and scientists, they're just trying to stand up ad hoc. There's a kind of a blending, if you will, between development environments and production environments. When it comes to data, that kind of all just merges together. And so the legacy processes around certification and accreditation don't necessarily apply directly into data operations. Security, where typically they would go into a UI and they would prove, okay, this classification control is met, and you kind of check through it, and that's part of the security process. That doesn't really work here either. And then the question is like, what is our MOA or MOU state on data use agreements between two applications or multiple agencies or foreign nations and in our country? So this becomes really complicated, and there's all sorts of classification restrictions, and we don't have any real good standards across between DoD and IC as to how to handle that. Everything has been bespoke. Everything was custom engineered because it was tailored to an application versus allowing any end user. And so what we've actually found, talking to 5 separate government organizations, is it's typically 2.5 months to get on a new data set. So meaning end user they know the data that they want finally, so that takes like 2 or 3 weeks, they find it. After that, it takes about 2 months to just get on the data and start using it as part of their mission. It's highly inefficient. And so when you're talking about thousands of users and thousands of data sources, that's obviously extremely highly inefficient for the government. So there's new approaches. This is not just a government problem. We've seen this in commercial industry, in financial services and healthcare, et cetera. And so there's new approaches to kind of streamline this and get them on the data within minutes. And so that's kind of why Immuta and Starburst have partnered together in the government, is to start solving this problem without having to write a lot of code or building large engineering teams. And so this new approach to access and control is quite critical. And it's really, at the end of the day, for the government, it comes down to 2 basic principles. It's this pendulum of, I want to move really fast. And in some cases, like if there's a 9/11 event, we will break rules, right? We will give anyone the data they need to go figure out what they need to figure out. But in many other cases, very rare, those cases come along. And so security with data is very different than traditional network security and the certification processes that we've gone through as we've deployed apps onto our classified networks. In data, it's about the rules on it and who can combine what and what methods could be potentially exposed. Is there encryption? Is there, have we removed certain entities out of there? Can we effectively identify those entities that are risky and remove them out of there? It's a very labor-intensive process. And then what also comes into it in that speed on the other side is a lot of times we have to write custom code to web services across all of these different systems because we've built applications over the past couple decades. And so to hook into those data sources, the speed is really dragged down by having to write custom code every time you want to connect into a new data source. And so this pendulum of how do I go really fast and be safe is the debate. And to extend that, what we tend to do is just make copies of the data. And that's part of the slowness, is we have to go request that program to go make a copy of the data, ship it to us somehow. So if you have access to cloud, you can throw it in an S3 bucket, or you actually physically put it on a drive, but it's extremely slow to go through that. And it's a one-time snapshot. A lot of these data sources, they're constantly creating new data. So how do you keep up to date? The second part is like classifying it. What's in there? What are the rules on it? Who dictates the policy? Who owns the policy? What's the MOU, MOA around it? Establishing all that takes quite some time, especially if it's across agencies or nations. And then the problem is, well, if you're the owner of this data, you have to protect it. If you hand it out as a copy, how do you oversee that? And so that becomes really complicated. And so what ends up happening is whereas we find customers in the government, they tend to just build massive role explosion of who needs to be informed as to who can do what, and this just slows everything down. And to put like numbers around this, just to think the scale, is we have on the left Immuta where we're really focused on a single way to enforce data policy. And on the right, you have Starburst, which is really focused on providing a single access point to all these sources of data across all your databases and storage systems. And if you think of the combination is that, on the policy side, if you have multiple data platforms, multiple geographies or agencies, organizations, so let's just say we're working on 5 partner nations, like the Five Eye community, working on multiple different data platforms. We have just only 5 rules on it. Just there, plus the directorates and different regulations and different types of tables we're building out of that, creates nearly 500,000 policies. There's just no way engineers or your average user could oversee all those rules. And then you add in different access patterns, right? The number of sources from different application systems, number of users, different storage formats from where they're coming from. It's nearly 1 million access patterns. So the problem here is, if we want to give access to data in a democratized fashion to end users in the government, where we know we're going to have classification restrictions, we know we're going to have isolated storage systems because of the regulations around these agencies and organizations, then we have to think through ways by which we can streamline access. And so at the core of that, to start it, is you have to separate policy from platform. So like in big data, we had to separate compute from storage so we could, query petabyte scale data. In this era where we want to democratize access to sensitive data, we have to separate policy from platform. So Immuta can hook into a compute layer like Starburst, and then Starburst can then federate out those queries to all these other storage systems, whether it's like in DSIGs, we could hit all the Oracle, the DSIGs brains in Oracle, or your SQL servers out there. Or if you're on cloud now, Redshift and S3 or Azure Synapse or Snowflake or Databricks. So there's all these different areas by which we can federate out these queries, enforce policy, because we've separated the business logic of the policy from the data of wherever it resides. And that allows us to get scale. And so governance users can just build their rules. Data engineers can inherit those rules and federate out these queries. And then data users can just consume that data from the tools of their choice, whether it's a BI or data science tool. And they don't have to worry about the policy or restrictions around it. And what that leads to is that accelerated data use is all about just simplifying how you get access and how you control it, right? So Starburst is the best in the world at providing like a single point of access to data, so they can federate out in a performant manner the ability to query all that data across all these storage systems. And what that immediately does is lowers the barrier to be able to rapidly get access to data, test it in a dev environment, and start to maybe use that in production. Second thing it does is that as we're accelerating that time to data, what it also does is, as you have these sensitive data sets made available in our catalog, what allows end users to do is be able to discover their data faster. They don't have to worry about writing code to query it. They could just use their tools and it just automatically happens. So now they're moving from what used to take a couple months to get on it to near instantaneous access to it. And what that does is, for the data engineering teams, because we can accelerate the time to data, we have it all governed, everything is audited, we can get through the certification process quickly. This holistically increases the productivity of data engineering teams that are being spun up to serve this democratized end users around your data environments and your data culture. And so to start, I'd like to hand it over to Justin really quickly to talk about the way a single point of data access to all of your distributed data systems.
Thanks so much, Matt. Really appreciate it. Thank you all for having me here. And I just want to start by saying thank you to all of you in the audience for the incredibly important work you do to keep us safe. Really, really appreciate it. So let me tell you a little bit about Starburst and how we factor into this. I think Matt set it up super well. Starburst was founded by the creators of an open source project called Presto, or now Trino as it's called. The name has changed recently. And I know that some of you already are using actually our open source version today within the groups that you work on. The project itself was originally created at Facebook and is used by leading internet companies for fast analytics across all of their data, improving accuracy and time to insight. And Starburst has expanded on that platform to deliver enterprise capabilities for the most complex organizations. Matt, if you don't mind going to the next slide. There we go, perfect. The way we do that is by providing fast access to all of your data, as Matt said earlier. We do that through a MPP query engine, so that is a massively parallel processing query engine, incredibly scalable, used by Facebook, Airbnb, Netflix, LinkedIn, Twitter, some of the largest companies in the world in terms of the data volumes that they're dealing with, around hundreds of petabytes of data and thousands of users. And in particular, we excel around high concurrency, where you have numbers of queries hitting the system at the same time. Starburst is really well built for those types of high scale applications, and really purpose built for data discovery and ad hoc analytics. By providing a single point of access, Starburst is a natural fit for data consumers looking to do data discovery and ad hoc analysis. If you go to the next slide, perfect. Ultimately what we're trying to do is keep your data consumers connected to their data, even if that data is currently being moved from one platform to another or exists in a variety of different data sources. And those data sources can be everything from relational database systems, streaming systems like Kafka, data lakes of really any variety. It could be on-prem object storage like MinIO, it could be Hadoop, or it could be cloud object storage like S3, Azure Data Lake Storage, or Google Cloud Storage, as well as even NoSQL systems. The beauty here is we have well over 40 connectors to different systems and really allow you to provide access to everything that you already have. And we do it with ANSI SQL. So it's a language that your team already knows. We provide JDBC and ODBC drivers and a REST API, so you can connect to popular BI and visualization tools like Tableau, Power BI, other tools that you may have, or even your own homegrown applications that you can write, applications that can speak SQL to our platform. And again, provide consistent data access across all of these systems. So very often what our customers end up doing is, maybe they get immediate value out of data in a data lake, let's say, but maybe now they want to extend beyond that data lake to other data sources, an Oracle database, an IBM database, a Teradata database. And they can now, with our platform, actually join a table in one system with the table in another system and perform that join in a very high performant way at scale using our platform. That then sets you up to actually do migrations behind the scenes without your end users even having to necessarily know. You might decide, I'm going to retire that Teradata system or that Oracle system and start to move tables off of Oracle, and I'm going to move them to S3, and I want to be able to query them there. Well, you can start doing that even as your end consumers are actually querying the platform, and you can do that seamlessly, kind of hidden from view for them. So really allows you to future-proof your architecture, and as I like to say, provide optionality. Actually, if you go to the next slide, Matt, that's a great segue to how we very much do that, particularly for those in data engineering and the owners of these data platforms. First and foremost, this notion of storage and compute separation, which I'm sure you've heard of, we were built for that from the beginning. Like architecturally, we are a query engine. The way you can think about it is we're like a database without storage. And that means that we think of every other possible database system or storage system as our own storage. And so that is true separation, which also means that if you're running in a virtualized environment like a public cloud or even private cloud where you're using Kubernetes or VMs, you can actually scale up and scale down your compute as necessary. It's very elastic, and you can get better cost utilization out of that by only scaling up when you need more machines, scaling down when you need less machines. A very simple example would be if you have a high load from 8 to 5 or 9 to 5 every day, you might want a larger cluster. And then maybe overnight, you only have a few night owls hitting the system. Maybe you want to shrink that cluster down. We can do that very elastically and save on those infrastructure costs. And ultimately, we're giving your engineers, operational flexibility to actually decide when ETL makes sense and when it doesn't, because you now have a choice for really the first time to decide, do I want to go direct to the data source, or do I want to do an ETL process and move it somewhere? And I think that's the beauty of our platform, is essentially you have the choice of where that data is going to be stored and how you want to interact with it. So with that, I will pause and I will turn it back over to you, Matt, and we can talk about how these technologies work together. Or actually, I think you're going to talk a little bit more about Immuta and access control.
Yeah, thank you. Yeah, correct. So just quickly hitting on, so if you have a single point of access to be able to quickly discover the data and then connect to it, and so you can query it, the question is how do you get around the security? How do you get through the policies to allow people to actually use it? And so that's where Immuta comes in. And we started in the government, so we obviously, we understand the classification guides and the complexities around policies, the complexities around like title authorities that the same user may, depending on what they're read into, is going to need access to different things. And so we always start with data discovery and classification. So the first thing we do in Immuta in our catalog is that we can classify it. So we look at a data source connected to us, connecting through like a Starburst. And what we do is we determine what are the different types of entities in there. And then we use that to drive how we build policy. So we can see that across all those different platforms, and it provides a consistent way for us to tag the data and then understand what it is. So that way we can actually apply rules. So what we've also built in the UI is the ability for any user to go in there, and we also offer a command line interface to do it programmatically, but users can go in and actually select how to build rules. So redacting content, masking, applying more complicated methodologies like anonymization and differential privacy. So in the cases of like human intelligence, how do we guarantee that our source's identity isn't going to be given up in the data in aggregate? So indirect identifiers, if you will. So like let's just say their height. If I got a 7'2" source, how do we'll automatically detect that's a unique outlier in the data, and we can null it out. So the policies are really easy to build, all GUI driven. And we have two types of policy: subscriptions, and then we have data level. So subscriptions, who can subscribe to it, who has a need to know about the data, and then the local data policies themselves actually enforce rules like masking, redaction, etc. And then the final thing we do is once you can connect to your data, you can control it, we need to prove that you've complied with the rules. And so we have a unified auditing layer, so we can see who is querying what data and why. Based on the purpose, based on the project, based on the data source, based on what that attributes from either PKI or Active Directory identity management systems, we can understand who they are, the queries that were run, and we can provide holistic reporting on that. And so that's what Immuta does. Together, what that means is that what we're doing is we're simplifying data access for every stakeholder, right? So we're securing it. We're reducing roles by implementing purpose-based access controls and attribute-based access controls with federated queries. What we're doing is reducing the complexity of like, hey, all these rules, let's just say in RBAC, role-based access, if I'm trying to limit you to a certain state, I'd have to write the rule 50 times. But if you're in Massachusetts, I could say as well, actually, all I have to do is write the rule once and say you can only see the data by which the state you're in. Right, and so it'll automatically only allow you to see Massachusetts because that's where you live. So it's reducing all these roles and making it simpler for compliance and security to understand how users are accessing the data. And again, what that does is it accelerates the time. So with that, the architecture, we're about to just jump into a demo here so you can actually see it in flight. But if you think about the architecture is that identity management connects into Immuta. We're able to hook into all your traditional IAM or PKI-based systems for authentication. We are deployed on the high side, so JWICs and other sensitive networks, as well as down to SIPRNet and NIPRNet. What you also see is that stewards and compliance can come and build the rules in Immuta, and then we can either feed out our logs or we can keep them, but we've integrated with all your major SIAM systems. And then we can also integrate with other catalogs, so we can collect all that metadata. So any data, let's say like with like Calibra, we can collect all that metadata and bring it into Immuta so we can actually enforce those rules. And then where Starburst comes in, of course, is the ability to hook into all these external systems. As the data consumers want to get access to this data, Starburst provides this wonderful means to federate out to different databases, cloud compute infrastructure, as well as business intelligence systems for the end users. And so with that, what we'll do is just give you a quick demo of a real world use case of the two technologies together. So I'll hand it off to Danny Holloway.
Thanks, Matt. So I'll be trying to put some of the concepts we talked to today into concrete terms and walking through the Immuta application as I do it. Give me 1 second to share my screen. And we'll start here at the data sources in Immuta application. So yeah, having spent a lot of time working with customers in national security and defense, trying to build the killer apps as Matt described them, one thing became abundantly clear was that as data sources became bigger and the real value was to be realized in the fusion of one source with another, and the need for our more technically capable workforce to start to do exploratory analytics, building dashboards and real-time application of AI ML, we were going to need a fundamentally different approach as to how we were going to get data sets outside of applications and into the hands of powerful analytic tools. So when Immuta came onto my radar, I was thrilled to kind of be a part of that revolution. And I think the unique combination of Immuta's global dynamic policy enforcement in combination with the Starburst approach to query anything, anywhere is uniquely poised specifically to get our users in national security applications out of the singular siloed processing of information and the analytics across global data sets as we start to take a new approach towards intelligence analysis. So, with that said, I'm going to walk through the application. We're looking here at a number of data sources here inside of an Immuta application that's integrated with a Starburst cluster. So I can see immediately that I've got 44 data sources that are visible to me. I can see they're backed by Presto technology, and I've got the ability to come here and request access. But for the purposes of this demo, I'm going to be focused on the data sources that I've got ownership and control over. And I'm going to be walking through some policy building and some queries to show both how we make data available to users and provide access using attributes, which could be coming from either manual tags, automatically applied tags, or tags that have been pulled in from external catalogs, whether it's Omni, Calibra, or some other system. And then I'm going to be walking through some fine-grained access controls using metadata and attribute values to control which fields might get redacted or which rows may or may not be returned to users based on the titles and authorities that are operating under or the areas of responsibility that they've got in their domain. So I'm going to jump into one of the data sets here. I've got two representative examples. One is a set of foundational intelligence global points of interest that we've pulled in and ETL'd from the OpenStreetMap project. And I'm going to go ahead and author a policy. I've got another user here. They are currently not able to see any data sources. And I'm going to go in through Immuta, and I'm going to write a policy to give them access based on attributes that we've pulled from an external source. So I can see here as the owner, I currently have myself as an owner as well as another administrator. I'm going to move over to our policies functionality, and I'm going to write a global subscription policy. These global subscription policies go across data sources, and they're really driven by tags and attributes. So things like, what is this data source? What function is it performing? What contents might it contain? And what types of users might need to have access to it? So I'm going to go ahead and start with one based on Title 50 authority. And I'm going to go ahead and allow any user with an attribute to start to get access to this system. So in here, we've got a number of attribute categories, and these are coming either from within Immuta or from an external source. But I'm going to actually look for a specific title, authority, and value. And I'm going to make sure that users automatically get subscribed. And I'm going to have this applied to data sources that are specifically tagged as Title 50 data. So with that, I can review the policy. Go ahead and get that created and activated. And this user still doesn't have access because I haven't tagged the data yet. But if I come over here and I look for my global events data, and I add a tag to this data set, I can now see that this tag is toggleable. I can easily add it, remove it. But if I go back to the user, and actually let me make sure, the other thing that we've got in this system is a specific policy globally that allows users to discover data sources and request access. In this case, I want to make sure that my Title 50 authority policy is going to trump that and be the trigger for who has access to this data source. And now I can see that the Danny Holloway member is now subscribed to the data source. If I toggle over to my application and I refresh the view of data sources available to me, I can now see that I've got a data source that I'm subscribed to, and I have full access to who also has access to this data, what are the data elements that the Immuta application is aware of, and I can get a sense of which tags have been applied, whether it be one of the ones that we have here prefixed with discovered that's been applied through our sensitive data discovery algorithm, or I can see whether there are specific attributes in this data set that are indicated by these policy indicators that may be protected. We have a combination of, just like we have subscription policies that are data source specific and globally applied, we've got data control policies that can be applied system-wide or specific to a data source. And so we can see that target name, because of the way that it's tagged, is going to automatically have policy applied against it and protected along with source name. And that's because these are tagged as PII. If I wanted to remove these policies, like source name, it is an organization, not a person name, I could go ahead and disable that tag. But I'll go ahead and dive into some more subscription policy details and show some of the control policies in a second. So now I'm going to look at one of the other data sources that I have in the system. And this is not as sensitive. It's a global POI. We're going to be using it sort of as foundational intelligence. And in this case, I want to write a subscription policy that allows me to give access to anyone in the intelligence analysis groups to any data sources that are tagged as foundational intelligence. And so if we look at the global POIs, I can see this data already came in tagged. So when it was registered with Immuta, the tag was applied. And then I'm going to go ahead back to our subscription policy, create a new subscription policy. I'm going to allow anyone in the group, Intel analysts, to get access to this data source. Provide a simple justification, and all of this gets audited. And I'm going to do this on data sources that are tagged as I'm going to use class, not foundational intelligence class. Create the policy. And then I'm going to go into our administration. I'm going to look at the Danny Holloway user, and I'm going to make sure that they're a part of the intelligence analysis group. And while I'm here, I want to call attention to a couple of the other attributes that we have in the system. These will come into play later as we write data control policies. In this case, I've got an attribute for area of responsibility countries, and I'm looking at 2 countries here, Mali and Tanzania. And then I've got the title authority that's getting access to any of the Title 50 data in the system. But I want to make sure that I have access to any of the foundational intelligence groups. So I'm going to make this user part of the intelligence analysis, Intel analyst group. And I'm going to go and look at the data source. And again, make sure that we've got our newly created policy triggering access to this data source. So we don't want customers, which makes it visible to everybody, but requires owner approval. In this case, we want to make sure that all of the people in the org that belong to the Intel Analysts group are automatically subscribed to the data. And then we can go back and verify that Danny Holloway now has access. We can look as the Danny Holloway user and look at our data sources to see that I now have access to 2 additional data sources as a subscriber, both a combination of the new POIs and the combined global POIs. So I'm going to go ahead and start to build some data control policies to move from access to control. You know, how do we look at the actual contents of the data itself and the attributes of the user to decide whether there are certain rows that should or should not be returned, or whether there's sensitive values that should be protected in most cases, and possibly by exemption, be allowed to get exposed for a finite period of time, or in some sort of, trigger some audit event that allows them to get access. One of the concepts that I want to highlight, particularly as it relates to purpose-based access, is the concepts of projects. And so projects are a construct in Immuta that allows me to define a set of data sources, a set of purposes, and a set of users that can work together for project, whether that be for a period of time or a distinct purpose. And that can potentially cause elevated or exempted levels of access to data, so long as somebody is operating within the scope of that project. We've also got the capability to be able to perform equalization across that project, so that users that belong to the project that may have different levels of access can operate in a sort of protected space where we can ensure that they can't perform a leaky write operation by writing out data attributes to a scratch space that they have access to, but somebody else in the project may not. So effectively, we can dumb down their permissions to the level of least access within the scope of the project, and ensure that all the rights that they're done are being protected and governed under that sort of least privilege, project equalized level of access control. So I'm going to go into a policy. I'm going to take a look at some data. I'm going to run a query start with the POIs. So in here, I can see that we've got name protected for this user, and I'm going to go ahead and run a query in Immuta. In this case, I do have a policy being enforced. And so what it's telling me here is, because of the policies, I don't have any access to the data in the rows currently. If I take a step back and look at why that is, we're going to be doing a number of functions here, one of which is going to be providing access to records based on which countries I have in my AOR. So I'm going to start to only show rows where the value in the column, where the user possesses an attribute in AOR countries that matches the value in country. And so in this case, I have a global data set that covers, it could be, whatever the collection mechanism is, it covers the entire world, but I want users, whether it's based on a regional center or alignment to some geographic combatant command, to have access to only the countries that they have attributes for. And I'm going to go ahead and make that system-wide. As I create this policy, save it. I'm going to now see that as I query this data set, I go into global POIs. I'm seeing records, and I can do a distinct on this, but I'm only seeing Tanzania and Mali. If I were to add other countries or take countries away, as an administrator, I'll go ahead and take away Tanzania, since all of the records I had initially returned were from that country. Actually, sorry, I lowered the whole attribute. So in that case, I deleted all the attributes, not the particular value. And in this case, I want to make sure that the users are still seeing records from Molly. I'll run the same query. And now I'm no longer seeing any of the records that have a value of country, Tanzania, but I am seeing things in Mali. And because of the data control policy here, we can see that these attributes and elements, the names, are being redacted. In some cases, this is a simple format preserving masking policy where we're replacing, I think it's the last 8 characters with asterisks. Some of these strings can be fairly long and still potentially uniquely identify something. So instead of this, system-wide global data control policy, I'm going to go ahead and write a specific policy to ensure that this name is fully redacted for all users except when they're operating under a particular purpose. So I'll jump back over to the administrator, look at the policy. And create a new data control policy. So we've got the policy in effect that's going to restrict rows to only the rows that the user has authority to view. But in this case, I want to do a masking function. And this masking function, I am going to, we'll apply a basic hashing function to the name. And I'm going to do this for anyone except when a user is acting under a purpose. And in this case, this is a somewhat contrived example. We use counterintelligence as a purpose. Create the policy, save it, come back into our query. Oh, this is wrong. Back into our query. And now we see that names are fully masked through the hashing function. And so I've got the same records, the same level of access, but I'm now seeing potentially sensitive information masked. If I wanted to change the scope of the project I'm operating under and use that counterintelligence purpose, I can see that there are a number of projects in the system, one of which is the public sector demo. And in this case, I have a purpose of counterintelligence that is activated when I select this policy. So I'm going to select the project and I'm going to query the data again. And I've got my public sector demo activated. And so in this case, now I'm seeing names in the clear. They're no longer being hashed. And as an administrator, I can come in and see not only did the user switch their current project to apply the counterintelligence purpose, but I can see that a query was conducted. And I can also see which query was initiated by the user, which query was ultimately pushed down to the underlying technology. And so you can see the addition of the where country in the set of Mali was applied based on attributes. And I see that it was executed under a counterintelligence purpose. And so these audit events can be fed into an enterprise audit system and tracked. They can be analyzed for anomalies, or they can just provide compliance with certain audit requirements. The next thing I wanted to do is create an additional policy on our actual event data. So I'm going to jump to that data source as the owner. And I can see that in addition to the global policies, I've got some potentially sensitive information in here. We've got a source name, a target name. This happens to be from the IQ's program, so it's an open source database, but let's just say that our source names are sensitive, and so the global policy we have in the system to obscure any of the targets and sources by masking the last 7 characters with asterisks isn't going to be sufficient. This is more sensitive than that. We can come up and create a new policy for this data source. We're going to mask, and we're going to make it null. And we're going to do source name and target name. We'll just do it system one. And I'll query this data. In this case, I'm actually going to jump to an external SQL tool. So we've got the built-in query editor inside of Immuta, which is really great as you're testing out policies and making sure that things are performing as a data owner as you expect them to. But most of the users, particularly those that are power users running SQL queries at scale and building analytics, are going to have sort of their own tool, and they may not necessarily be interacting with the Immuta UI. In this case, I've got dbeaver and an open source community tool for connecting to a number of different databases and running SQL queries. And I've got a direct connection to the Starburst cluster that's integrated with Immuta. It's important to note something unique about that native integration. So in this case, we've actually got an Immuta component that's deployed to every node in the Starburst cluster. And what that means is that those policies that have been created inside of the Immuta application through our policy building wizards are going to be enforced natively on the nodes themselves. So you've got all the MPP performance and the ability to run these queries at scale across data sources with the power of a universally defined data control policy and access control policy, so that the functionality and capability that was formerly implemented inside of the applications that were sort of the gateway to this data can still be enforced consistently across a variety of technologies, whether they be NoSQL databases, relational databases, other sort of compute infrastructure for streaming analytics. So you define one policy and have it enforced across all of that. And so you can still satisfy your governance requirements with the full traceability and audit visibility, but you can work inside of a tool like dbeaver. And so in this case, I'm going to be running a query to look at aggregate intensity across events, and I'm going to be, after this, I'm going to have to remove the group by, which is going to use the sensitive elements that I just nulled out. And go ahead and run this. I've got some conflicts with my policy. Okay, so in this case, we're looking at reporting about events, and we can see that we've got some negative sentiment events being reported. Our target name is being obfuscated. We can still see, which country is the event being directed at, which country is the event occurring in, and then which country is reporting on it. So in this case, we can take a look and potentially build analytics over time to take a look at how negative or positive events are occurring globally, at least within our AOR. But looking at this in SQL is not quite as useful, and not everybody's a SQL wizard. So I've also got an example here where I've got a Tableau BI tool connected to the same source. And I'm going to go ahead and refresh the tables that I have access to, because I've done a number of different operations to write policies. So now I've got my global POIs as well as my event data. I'm going to go ahead and add my events data and start to build out a sheet. Before this, I had gone ahead and prepared a look at categories and subcategories of POIs based on the countries that I have access to, so that we could take a look at sort of demographic data and take a look at maybe some of the unique neighborhoods and communities that we might want to dive deeper into. Go ahead and re-add an attribute to my user to make things a little more interesting. And I'm going to build out a new sheet. Okay. Looks like we're running short on time on demo. The only thing I'll highlight here before jumping back in is we've got both the queries that were being run from within Immuta as well as through our analytic tools tracked here in the audit log. We can see which purposes the users are operating under and how queries are being modified based on the policies that have been defined in the system. I want to make sure we've got enough time for questions, so I'll go ahead and wrap the demo here, but look to the chat or hand the mic back over and we can take questions as they come in.
Hey, Danny, great, thanks. I will jump in here. I'm gonna go in ahead and see if we have anyone that's come through. As a reminder to the group, if anyone has any questions, please feel free to put those in the Q&A pane right now. I'm gonna take a look. Okay, we have one that came in. I think it's for the Starburst team. How does Starburst handle situations where data sources are globally distributed and in some cases will be disconnected? Specifically, those sources are disconnected for a period of time and then back online.
Great question. Well, I can answer certainly the first part of that question. Maybe my team has other thoughts, but I will start by saying one of the capabilities we offer, and let me turn on my video here. I realized you can't see me. One of the capabilities we offer is a new feature that we call Stargate, Starburst Stargate. And I'll explain what that is. Stargate allows you to actually have a connector from one Starburst cluster to another Starburst cluster, which allows you to efficiently push down analytics to that particular region. Like, let's just imagine for a moment that you have multiple data centers or multiple AWS regions even. You've got an AWS region in EMEA and an AWS region in the east of the US. It may not be the exact setup for you all, but you get the idea. You could actually have a Starburst cluster running in both environments, and those clusters can talk to each other. So if a query comes in to one Starburst cluster, you need to join a table that lives in that one geographic region with a table that lives in another geographic region. Those clusters will talk to each other and actually push down the analytics to that region as much as possible to minimize data transfer across that network. So in particular, our commercial customers see value in this around minimizing egress charges from one cloud to another. If they have a multi-cloud strategy where they've got Azure and AWS and Google and an on-prem cluster, we can really minimize that transfer and therefore minimize egress charges. Another application is around data privacy or data sovereignty rules, where GDPR or other regulations in Europe in particular require that data created in Switzerland has to stay in Switzerland. And so they could have a cluster in Switzerland and a cluster in the US, and again, ensure that no data leaves Switzerland that isn't supposed to leave Switzerland, but still get the analytics done. So long story short, we're able to provide global connectivity regardless of geography, and we can get particular performance and efficiency using this Stargate, really Starburst to Starburst connector capability. Now, if something goes offline, obviously we can't connect to it at that point. We can't defy the laws of physics in that respect. But it's simply going to say that that connection is no longer active, right? So when that comes online again, you'll be able to connect to it again. The one thing I would add, if this is applicable for your use cases, we do have caching capabilities as well built into the product, so you could actually cache data if you wanted to from some of those data sources. So, for example, one use case that we see again in our commercial customers around this would be, an OLTP database, a transactional database like Oracle. Maybe you want to query some data that lives on that OLTP database, but you don't want to put tremendous strain on it because it is an active online, transactional system. So you don't want to strain it or slow it down or bring it down. So you might leverage caching, for example, in that case, and periodically refresh that cache so that you don't actually have to go direct to the source every time. You can just go to the cache and get the results that way. So there are a few creative ways that we could work with you around that. Hopefully that answered your question. If not, please feel free to ask again.
Awesome. Thank you, Justin. Another one that came in, and we're right at time here, so I'm going to ask this one quickly. Matt, I think you might want to potentially jump in, but how can Immuta and Presto accelerate the adoption of AI applied to mission data?
Yeah, so a lot of these missions, when the most basic concept, you have to merge data sources together as part of developing, any type of machine learning or AI initiatives. And usually the drag on that is when I start to combine, 5, 10, 15, 20 sources. So the ability to catalog that data and provide it to end users so they can get a development environment up and running and credited on a network, especially classified systems. That's an area where the two of us, we can help accelerate that very quickly. So get a dev environment up and running, get an authority to operate, utilizing reciprocity, and then getting them on the data, start merging it with rules being applied. That's one area. The second area is when rules change on data, when your originating data owners or MOUs change, how do you know which models trained on that data? And that you actually have to bring a model down, retrain it based off of the new rules. So for instance, we may null out a whole column that may change a model. So between the two of us, Starburst can provide the consistency and access to the data, and Immuta can then let you know if policies change, how it's going to impact your models, and keep them up to date, so that way you're always ahead of the game and not reacting to issues.
Yeah, I think that all makes a ton of sense. I'll just simply say, data access is kind of the prerequisite to doing AI, in my view, right? Like, you need to have access to the data in order to build the models in the first place. And I think that's part of what we can help, work on together.
Awesome. Well, I think that's a great place to stop for today. So thank you, Justin. Thank you, Matt, Nancy, Danny, everyone who's involved. If anyone on the call would like to learn more, you can visit immuta.com/demo, or we've also included Matt and Justin's contact information at the bottom of the screen there. So like I mentioned before, a copy of the slides and a recording will be sent out to everyone who's on this call. And again, if you have any questions, please feel free to reach out. Thanks, everyone.
Awesome. Thank you.